welcome you all to this 12th annual Summerhays Lecture. This lecture series is made possible through the generosity of the Summerhays family, connected with the Summerhays Music Company. The Summerhays family have long been supporters of the College of Physical and Mathematical Sciences, dating back to the 1960s when they funded the Summerhays Planetarium. I remember as a BYU student in the 1970s often enjoying going to that planetarium. In fact, I remember it being a favorite place to take a date. In fact, I recall shortly before proposing to my wife that I took her to the planetarium show. And I've wondered if the Summerhays family had any idea of the romantic possibilities of a planetarium at the time they made that donation. The planetarium has since been replaced by the Royden G. Derrick Planetarium, but in 2003, Brian Summerhays, the son of Hiram, his father, who had constructed given the money for the construction of the planetarium, started this lecture series in honor of his father. His father had a keen interest in unifying science and religion, and so Brian funded this lecture series in honor of his father. So I'm delighted to introduce tonight's 12th Summerhays lecturer, Professor John Lamb, from the Department of Chemistry and Biochemistry. Actually, Professor Lamb recently retired just a month ago from years of distinguished service at the university. Professor Lamb graduated from BYU with high honors in 1971 and received his PhD from BYU in inorganic physical chemistry in 1978. He joined the faculty of the BYU Department of Chemistry and Biochemistry in 1984. Professor Lamb has won numerous awards for his teaching and research in macrocyclic chemistry, ion chromatography, and liquid membranes, including receiving BYU's highest faculty honor, the Carl G. Mazur Distinguished Faculty Lecture Award. During his career, Professor Lamb also served as Executive Director of Research and Creative Works for the university, Associate Dean of Undergraduate Education, and Associate Chair of the Department of Chemistry and Biochemistry. For the past several decades, Professor Lamb's research has been focused on finding better ways for analyzing complex mixtures using chromography and membrane separations. From 1998 to the time of his retirement, just a few months ago, Professor Lamb was the Elia A. Butler Professor of Chemistry at BYU. So please join me in welcoming Professor John Lamb as our lecturer.
Well, thank you for coming tonight. And I want to thank Tom for that kind introduction, which they asked me to help write. And I want to begin by thanking and acknowledging the lovely Sister Lamb, who is going to be running the slides for us tonight. Let's begin with a story, shall we? In the middle of the 13th century, a Dominican friar named Thomas Aquinas was instrumental in laying the foundation of accepted cosmology for centuries to come. And just as a reminder, cosmology is the branch of natural philosophy which describes the structure of the universe, as you probably know. He had been born in a small town in the center of the Italian peninsula. You'll remember that Italy as a country didn't exist in those days. As a member of the gentry, he was educated from an early age, and despite his family's going to the extreme of imprisoning him for a year to prevent him from doing so, he entered the Dominican order. He was tutored under the finest mentors of the age in Paris and elsewhere, moved to and taught at several respected schools published widely, and in short, he followed the same kind of career path that leads to fame and fortune in the modern academic world. And as is true today, his lasting legacy resides in his writings, chiefly among them the tome entitled Summa Theologica. Several of his writings became so widely used in the schools of the so-called scholastics that for centuries, even until today, they became a standard part of the theological curriculum. And as is often true today, so it was then, He who writes the textbook governs the curriculum. Indeed, Aquinas' ideas became so well entrenched that they took on a special status, which happens to be the focus of my presentation tonight, namely dogma. Now, let me clarify up front, for our purposes here, I make a distinction between dogma as I would spell it with a small letter d, and that beginning with a capital letter. Some churches proclaim dogmata, that is, very specific points of belief which true practitioners of the faith must adhere to. In my remarks, I'll be using the term dogma with a lowercase d, that is, in a broader and more informal sense. Dogma being a belief which in one's mind is so well established, it may not be questioned even in the light of overwhelming evidence to the contrary. One can be dogmatic about a particular belief of virtually any kind, formalized or otherwise, religious or scientific. And because this can be an impediment to finding truth, as I will discuss, I've entitled my presentation, The Dogma Trap. Anyway, back to our story. Aquinas was well respected in his day, and his writings have endured the test of time because he was indeed a giant intellect. He was given the moniker Dr. Angelicus, which means exactly what it sounds like, and made a saint not long after his death. He's given much credit for his efforts to harmonize revealed religious truth and the understanding of truth according to reason and the best science of his day. Like many today, myself included, he took the position that faith and reason are both legitimate sources of truth and that they can and must mutually conform to the same truth. He made the argument that the study of nature and the application of reason were equally valid to revelation in finding out the nature of God and his creations. Now, the best science of Aquinas' day was that of the ancient Greek philosophers, like Alexander the Great's tutor, Aristotle, whose writings at that time were in the process of being rediscovered, or better said, returned to the Western world through the medium of the Islamic world. 13 centuries earlier, Aristotle had laid out a model of the universe based on observation and reason, which had endured with some modifications for all that time. Let's look at the basic elements of the most simple form of this model, shall we? We have the Earth at the center of the universe, the planets or wanderers, including the sun and moon, orbiting around it in circles generated by perfect hollow crystalline spheres, and the fixed stars beyond that, embedded in another sphere. This all seemed quite consistent with Scripture to Aquinas, so in keeping with his effort to bring together the truths of science and religion, Aquinas pictured the cosmos with the Earth at the center, the home of man and the central focus of God's creation, and the perfect unchangeable heavens in concentric spheres, homes not only of the planets now, but also of the various ranks of angels, till we encounter the outermost realm where God resides. The harmonizing of science and religion in this way was a great strengthener of faith for Christians and remained so for hundreds of years. Of course, you recognize that this isn't the model that we picture the universe today. The switch to a sun-centered solar system and ultimately to galaxies and an almost infinite universe with a mole or more of observable stars. Chemists will know what that means. If you don't, ask a chemist next to you. That was not easy to make that transition. How so? Well, I want you to imagine yourself a university don in the 16th or 17th centuries, hundreds of years after Aquinas. You're standing in front of a class of enthralled disciples in the majesty of your academic gown, reciting in high-sounding tones the time-honored and venerated truth of Aristotelian model of the world. Generations upon generations of your predecessor professors have done likewise and won admiration and esteem. Why should you doubt the absolute truth of it? And what would you do then If an upstart like Copernicus or Kepler or Galileo came along in the 15th or 16th centuries with new observations and a new sun-centered model that refuted your teachings, in your mind, the Aristotelian model, or we could call it the scholastic model, of the cosmos has become more than a good idea, it's become entrenched to the point of being unquestionable. In other words, in your mind, it has become dogma. That's with a small d. It would surely be unsettling to you that these men were promoting a new sun-centered model with heavenly bodies that are not perfect homes for angels, wouldn't it? But why take them seriously if Aristotelian model dictates otherwise? To accept their new science would be tantamount to coming down from your ivory tower and admitting you were wrong. And there goes your reputation, and maybe your retirement too. Now, to be fair, not all academicians and churchmen, who for the most part were the academicians at that time, felt this way. Many were open to new ideas, but enough were not, so that, to quote Stephen Mason's book, A History of the Sciences, in 1615, Galileo was summoned before the Inquisition at Rome, and there he was made to abjure the Copernican theory on pain of death. The propositions that the Earth rotated on its axis and that it moved around the sun were officially declared to be false and heretical. And in 1616, the work of Copernicus was placed on the Index of Prohibited Books, not to be removed until 1835. Now, in the end, Galileo spent the latter years of his life imprisoned by the Vatican over this new cosmology and was lucky to escape with his life. Now, to be fair, Protestants were no less dogmatic about the issue, and both Luther and Calvin, who were contemporaries of Copernicus, rejected the new science as well as heretical. As to the final outcome of our story, in the end, scientists, sooner, and religionists, later, both came to accept the transition to a new model of the universe. Today, virtually every human on the planet has not a whiff of reluctance to think in terms of a universe consistent with a sun-centered solar system, with an unimaginably large number of stars and galaxies. Yet we shouldn't take for granted that this has always been so. For many, it was a long, agonizing slog to make the transition. And dogmatic thinking was the primary slogifying influence, if you'll permit me to invent that term. The story we've reviewed illustrates as well as any how the confluence of science and religion provides the perfect opportunity for exposing dogmatic views. One mustn't assume, however, that it was only religious practitioners who fell into the dogma trap on this occasion. Many scientists were slow to give up their traditional teachings as well. Moreover, it would be hard to make much of a distinction between these two groups, scientists and religionists, in that day, as the academy was much different then than now in the sense that the two groups were composed largely of the same persons. The university and the research laboratory in those days were often staffed by professor priests or monks, and indeed Copernicus himself was a member of a minor order and received his doctorate in canon law. Even those not formally associated with the priesthood made religious thinking an integral part of their academic work. This state of affairs actually persisted and continued to persist for centuries. Even Newton, who was an academician much later and became known as the father of the mechanical universe, found himself working at least as much on Bible-related inquiries as on the physical world he came to elucidate. Indeed, Newton had to be careful to obfuscate his true religious beliefs in order to maintain his Lucasian chair at Cambridge. Given that the Summerhays Lectures focus on the relationship between science and religion, I've chosen to address how dogmatism can be an impediment to progress in both areas of pursuit, as so well illustrated in the story of the demise of the Aristotelian model. But given the limits of time, I'd like to focus my remark on three theses. Luther had 95, and I could probably match him, but we don't have time. My three theses are these. First, science and religion are both built on faith. Second, belief systems in both arenas embrace specific articles of faith, both formal and informal. And third, Belief systems in both arenas are susceptible to dogma traps, which impede their pursuit of truth. Of course, the pursuit of truth is central to the mission statements, to use a modern term, of both science and religion. Indeed, they share at least one common goal, which might be summarized as follows: to help us understand the world we live in, how to cope with it, how to control it, how to view our proper place in it, and how to achieve the greatest possible personal fulfillment in it. Now, as to thesis number 1, there's certainly nothing new about asserting that both science and religion are grounded in faith. In the realm of religion, reference to faith goes almost without saying, so we need not dwell on that. But the principle applies equally to science. Let me illustrate. I imagine that everyone in this room has taken at least one science class in his or her life, sometimes welcome, sometimes not. And as you studied the structure of the atom or the Krebs cycle in living systems, did you not take it on faith that the instructor wasn't just making all that stuff up? And that the $200 you spent on that textbook wasn't an entire waste because the content of every beautifully illustrated page wasn't a gigantic fraud? Yes, of course you did. You took it on faith. The only way science can advance is if each successive generation has faith in the claims of careful observation, analysis, and reporting of its predecessors. None of us has time to go back and double-check the painstaking work of Rutherford or Pauling or Watson and Crick. Newton is said to have claimed that he saw further because he was standing on the shoulders of giants. But he had to have faith that those giants weren't really just round-shouldered midgets in disguise. So it is with all of scientific advances. Lord Kelvin and my textbook and many experts over the years have testified to me that the second law of thermodynamics is true, that no one has ever observed otherwise. So I believe them and move on. I have my own research topics to pursue. But I'll keep my eyes open and be ready for that Nobel Prize if I happen to notice a provable system that does not obey that law. And it is in this latter assertion that I can avoid the dogma trap related to the second law of thermodynamics, which hasn't become dogma if I keep an open mind, as I will discuss later. But for now, I'm still addressing that first thesis, namely that science and religion both build their systems of truth on faith. And as I mentioned earlier, it is at the confluence of the two that dogma often is unveiled. Consider this. The high priest of atheism, the biologist Richard Dawkins at Oxford, and author of the book The God Delusion, may bear his testimony that there is no God because you cannot observe him scientifically. He may say, how can you believe in God? Have you seen him? The religionist might answer, how can you believe in electrons? Have you ever seen one? He may answer, no, but I have seen their effects reproducibly in the laboratory. The religionist may answer, in the same way, I have seen the effects of God in my life and the lives of others. In both cases, the proponent has faith that he or she sees the effects, the one of God, the other of the electron, deduces the existence, and has faith that her conclusion is a correct one. Furthermore, in both cases, the proponent relies with faith on the testimony of witnesses, those who have more direct experience than he or she does. The religionist strengthens his faith in the testimony of prophets who have seen or had close experiences of the divine. The scientist has faith in the testimony of predecessor scientists who have performed and reported the results of their experiments. Of course, one important difference is that in science, reproducibility is the basis for faith. In religion, on the other hand, faith-promoting events are rare and not predictable, and therefore not reproducible in the scientific sense. But that doesn't mean they aren't real. Let me ask you, if an event that happens only once every few hundred years or a few thousand years to one person, but not another, is it not real because it is rare? The answer to this question, of course, depends entirely on how one applies what is a fundamental article of faith in science, specifically the idea of reproducibility that we already mentioned. It is an underlying fundamental article of faith in science that for a scientific assertion to be established as true, it must be underpinned by observations that are reproducible. Reproducibility is a widely accepted principle in science. It goes without saying, and some might treat it as dogma, insisting that it be applied to test all hypotheses. Now, you scientists might be offended by the classification of the principle of reproducibility as dogma, since the title of my talk rather puts dogma in a negative light, doesn't it? Let me clarify, though, that every belief that is held to be dogma is not false or bad. If dogmatism is a problem, the problem is not with the belief itself, but with the holder of the belief. This is an important distinction. Let me repeat it for those of you who may have dozed off. If dogmatism is a problem, the problem is not with the belief itself, but with the holder of the belief. I called reproducibility a fundamental principle of science. I believe in it, my colleagues in chemistry believe in it, we all apply it almost religiously to our practice of science. It's a good principle. But like any good principle, it becomes problematic when it becomes an unquestionable principle. That is, you are not allowed to question or modify it under any circumstance. You must apply it to every circumstance. At that point, it becomes dogma in your mind. At that point, the holder of this belief states that for any belief, to be valid, it must pass the test of reproducibility. Period. End of discussion. It's my way or the highway. It's Galileo in prison. It's the heretic in the fire. It's not just an article of faith. It's the one and only true way. Anyone who questions it does not merit respect, or maybe even life. So you might ask, is it not okay to have so much faith in a principle that it becomes so close to unquestionable that for all intents and purposes it is? I guess in my mind there's a subtle but important distinction to be made along these lines. I envision in each person's mind a certainty spectrum, ranging all the way from I really don't know and I probably don't care on the one extreme, and dogma on the other. It is at the extreme endpoint that we may cross the subtle border between close to unquestionable and completely unquestionable, that is, dogma. That's where we become trapped. I'll return to this idea in a few minutes with some examples. But first, let's move on to my second thesis. Belief systems in both arenas, science and religion, embrace specific articles of faith, both formal and informal. Many religions post formal statements or articles of faith. Mormons have 13, you know that. The National Baptist Convention has 18. Maimonides listed 13 fundamental principles for the Jewish faith, and Islam lists 6. And of course, the big daddy of articles of faith for most Christians is the Nicene Creed in its various flavors. For religious believers, these points fall very close to or on the dogma end of most people's certainty spectrum. Science also has its articles of faith, though they are seldom discussed or even given a thought by practicing scientists, except when teaching introductory general science classes. BYU's Physical Science 100 class lists 6 so-called self-evident truths, and I invite you to glance over them. Let's do that together. I'm just going to read the title, and I'll let you read the explanation. The first is existence. I guess that's a pretty good article of faith. The second, causality. The third, position symmetry. The fourth, time symmetry. The fifth, non-contradiction. And finally, Occam's razor. We don't have time to discuss these in detail here tonight, unfortunately, but if you want to learn more, take the class. Another article of faith in science might be, if it's published in the journals Nature or Science, it must be true. thus expressing faith in the principle of peer review. And there are others that you might think of. As is true with the articles of faith in many religions, most scientists hold these ideas to be near or on the dogma end of the certainty spectrum. So these are the rock-bottom articles of faith in both science and religion. But it's not here that we often encounter the ill effects of the dogma trap. More often, troubles arise with some of what we might call the lesser articles of faith. Now, what do I mean by these lesser articles? Well, each person, scientist or religionist, has been taught or has developed in her own mind a certain set of beliefs and understandings, which perhaps, when first encountered, found themselves somewhere in the middle of the certainty spectrum, but which over time have been repeated so often, challenged so seldom, become so comfortable, that they have gradually and inexorably crept along the certainty spectrum toward the dogma end. Without even realizing it, the person has become dogmatic about that particular idea. And this is where we often run into trouble, and this leads me to my third thesis. That is, belief systems in both arenas are susceptible to dogma traps which impede the pursuit of truth. Perhaps the best approach to expounding this point is with a series of examples. They're always more fun, right? We've seen already how the dogmatic adherence to the Aristotelian model of the cosmos was an impediment to the advancement of our understanding of astronomy, impacting both the scientific and the religious camps. I'll take my next example from the realm of scientific research with an episode much closer to home and to our own day. In March of 1989, two scientists at the University of Utah, Stan Pons and Martin Fleischmann, announced that they had discovered cold fusion. The story is a long and fascinating one. Lengthy books have been written about this episode. It even impacted BYU and me personally in certain ways that I don't have time to go into here. Just to put their discovery in perspective, though, for those unfamiliar with nuclear fusion, this is the process that powers the sun. It comes about when the positively charged nuclei of two atoms smash together and combine to form a single heavier nucleus, plus some byproducts, including a lot of energy. Scientists have been trying to create fusion reactions on Earth for decades, but the problem is that the positively charged nuclei of the atoms repel one another. So effectively, in fact, that it's almost impossible to get them close enough to fuse. The first significant success was to generate uncontrolled fusion in the form of a hydrogen bomb. The heat of an atomic fission bomb being used to raise the temperature of the hydrogen atoms high enough that the atoms are moving fast enough to overcome their mutual repulsion. But hydrogen bombs aren't a good way to generate electricity. They tend to destroy stuff. So the holy grail of fusion research has been to find a way to make fusion occur under controlled conditions. This is the challenge. Normally, this would require raising the temperature of the hydrogen to millions of degrees, as on the sun. But here's the rub. What kind of a container could house the reaction without being vaporized at the millions of degrees required? Ingenious but very expensive ways of doing this have been investigated. I can remember as a boy being promised that within a few decades controlled fusion would be online and limitless energy would be available to power human civilization for millions of years into the future. And many of you are old enough to remember that promise. Just me? Well, decades have come and gone, and we're still not much closer to bringing controlled fusion into reality, leading to the oft-quote cynical saying that fusion is the energy source of the future and always will be. So the announcement of Pons and Fleischmann that they had achieved fusion at room temperature came as a real bombshell to the scientific community. If true, it would sidestep the high temperature requirements altogether and make the scientists and the University of Utah very, very, very rich. The only evidence these researchers had for fusion, though, was a great deal of heat from their reactor. So much so, they said, that it melted its way down through the tabletop. From the beginning, there were serious problems with their claim. First of all, heat is not an accurate signature of a nuclear process. Simpler explanations would involve chemical processes, which had nothing to do with nuclear interactions. Second, their results were not reproducible even in their own laboratory. Third, as time went by and others tried around the world, the result could not be reproduced in most other laboratories either. Fourth, no one in their lab or others could find any of the other telltale signs of a nuclear process, like neutrons or gamma rays. And fifth, their claim flew in the face of a huge body of accepted knowledge about nuclear processes. Now, how does this episode relate to our topic here? First, let's admit that anyone, including scientists, can make an honest mistake. That's not the point. The point is that as time went by and as more and more evidence mounted up that the process they had observed was not fusion, the scientists did not keep their minds open to that possibility, but instead became more and more defensive and more insistent that they were indeed dealing with fusion processes. If their result did not square with current nuclear theory, then the entire body of nuclear physics needed to be revised. That should be easy. It is clear that over time, their belief was sliding gradually along the certainty spectrum toward the dogma extreme. Their faith in their belief could not be shaken by any amount of evidence to the contrary. Pons and Fleischmann had fallen into the dogma trap. And there are still believers in cold fusion even to this day, as you can read about online. Just Google cold fusion times or attend the next international symposium, which is scheduled in June of 2015. Not here. In another example close to home, but this time in the realm of religion, let me point out how frustrated Joseph Smith often became with the people of his day, both within and without the church, in trying to introduce them to his ever-widening vision of eternal principles. Towards the end of his life, he is quoted as saying this: "There has been a great difficulty in getting anything into the heads of this generation," he said. "It has been like splitting hemlock knots with a corn dodger for a wedge," that's a piece of cornbread, "and a pumpkin for a beetle," that's a mallet. He goes on to say, "I have tried for a number of years to get the minds of the saints prepared to receive the things of God, but we frequently see some of them, after suffering all they have for the work of God, will fly to pieces like glass as soon as anything comes that is contrary to their traditions." The traditions that Joseph bemoans are essentially beliefs that the saints had come to regard as dogma. And finding themselves in the dogma trap, their progress toward ultimate truth and exaltation was hindered. D&C 19 provides us an example of just how easily we can fall into a trap, believing dogmatically that we understand a principle when in fact we don't. And we can learn a real lesson from this episode. Speaking of the judgment of the wicked, the Lord states, "It is not written that there shall be no end to this torment, but it is written endless torment. Again, it is written eternal damnation. Wherefore I will explain unto you this mystery. For behold, I am endless, and the punishment which is given from my hand is endless punishment, for endless is my name. Wherefore eternal punishment is God's punishment. Endless punishment is God's punishment." Now, before this declaration, I'm sure there was absolutely no doubt in anyone's mind what endless punishment meant. It was an obvious point of dogma, albeit a rather benign one, a mini dogma, if you will. There probably wasn't a Christian minister alive who wouldn't argue most vehemently that God intended to inflict punishment on the wicked for all eternity to come, including many of the saints. Yet here is an example of the genius of Joseph Smith. He was not dogmatic about his beliefs. and that meant he was teachable and open to the truth. And frankly, this truth makes a lot more sense to me than inflicting infinite punishment on a person for a finite number of sins. Finally, here's another brief example of the dogma trap catching some scientists in its clutches. In the early 20th century, a meteorologist from Germany named Alfred Wegener followed up on an observation that most children, maybe including you, certainly me, made when they were young about the map of the continents. Namely, that the eastern outlines of the Americas roughly match those of Western Europe and Africa. Various other similarities, including fossil species and land formations, also seem to line up. So Wegener proposed that at some time in the distant past, the continents must have been joined and drifted apart. He was viciously attacked by the geological scientific establishment for proposing this, partly on the grounds that there was no known mechanism for continents to move, and therefore it was dogmatically believed that this was impossible, and partly because Wegener had the temerity to not be a geologist. It was not until after Wegener's untimely death by freezing in Greenland, an ironic way to go for a meteorologist, I think, that plate tectonics became one of the rock bottom, if I can use the pun, principles of terrestrial geology. Now, a similar dogmatic adherence to uniformitarianism is cited among geologists, also for feet dragging and accepting the catastrophe-oriented explanation for the demise of the dinosaurs 65 million years ago by asteroid impact. We now know the true story. So there are lots of examples that we could cite here from both science and religion where even well-educated men and women have fallen into the dogma trap. I spoke earlier about scientists who insist that because the claims of religion cannot meet the test of scientific reproducibility, that they are not valid, and how this assertion for some has taken on the aura of dogma. The author Louis Vaughan, in his book The Power of Critical Thinking, defines a term for this almost religious mode of thought: scientism. You've heard of Mormonism? This is scientism. He states, science is not scientism. One definition of scientism is the view that science is the only reliable way to acquire knowledge. Put another way, science is the only reliable road to truth. But in light of the reliability of our sense experience under standard unhindered conditions, this claim is dubious. We obviously do know many things without the aid of scientific methodology. He cites love, beauty, honor, joy, some of the most important things in life, I would assert, among the intangibles that defy exact scientific analysis. He goes on to clarify the role of true science without the dogma of scientism. He says science may not be the only road to truth, but it is an extremely reliable way of acquiring knowledge about the empirical world. Some would say that science is reliable because it's self-correcting. Science does not grab hold of an explanation and never let it go. Instead, it looks at alternative ways to explain a phenomenon, tests these alternatives, and opens up the conclusions to criticism from scientists everywhere. Now, history and today's newscasts are replete with examples where the dogma trap has captured the unwary. The consequences range, and there are consequences. The consequences range from the relatively benign to the downright tragic. Let me offer up just a few more examples for your consideration. I give you 9 assertions which have been treated by some as dogma, and I invite you to contemplate the consequences of dogma for yourself. Let's go through them one at a time. The first is the idea that the black race is inferior and are natural slaves. Second, the Bible story of the creation took exactly 6 24-hour days. You'll notice that these come both from the realms of science and religion. Third, eugenics is a true science, and its principles demand that the strong remove the weak from the gene pool. Here's another one. Allah will greatly reward the faithful Muslim who takes the lives of infidels. And another one close to home. To be a true Christian, one must believe the Nicene Creed, so Mormons are not Christians. Social engineering justifies murdering millions of your citizens. Only carbon-based life is possible. Wealth concentrated in the few will trickle down to the many. Warren Jeffs speaks for God. And I imagine you can think of a lot more. But I've talked long enough. Mark Twain said, "It's a terrible death to be talked to death." And he was right. Anyway, over the last hour, or 45 minutes, chances are that with at least one of my examples, I've managed to raise the blood pressure in your brain a little bit. But I hope in this short time I've convinced you that keeping an open mind is the best path to seeking truth and making progress. Dogmatic thinking is a trap. By contrast, I imagine most of us here admire Joseph Smith. And when you think about it, it was his willingness to think outside the box and to accept and implement the unorthodox, his humble background and his teachable attitude that permitted him to accomplish so much in such a short lifetime. Of course, he didn't throw all reason and good judgment to the wind, and neither should we. But let's not require a wedge and a hammer to pound fresh ideas into our heads as he bemoaned. But instead, let's follow his example and be open and creative in our thinking, amenable to what the Lord has to offer us, avoiding unyielding dogma. As Brother Joseph stated, if there is anything virtuous, lovely, or of good report or praiseworthy, we seek after these things. Thank you.